Professor Raghav from Delhi Technological University. First time we started working on drone remote sensing with Professor Raghava only. And he was introduced by Dr. Sefali Agrawal to me. So when we visited his lab, it is a lab where all the students are busy in developing low cost to very expensive drones, both quadcopters and also fixed wings. Then we are so excited, me and Dr. Vishwanathan from IRA, on the suggestions from our then Honorable DG Saab, we visited him to see if at all we can use the drone technology for different agricultural applications through some of the program on NSF. And that was the first interaction we started with Professor Raghava. Then immediately, so quickly, we could take up that program, and he could integrate it with the different sensors and came down to take up some of the images in IRI. And finally, we have been asked to showcase to Honorable Prime Minister Sir in the PC Unnati Mela in IRI, and there his contribution is unbelievable. So that was what kind of a contribution he had made through his active students from Delhi Technological University. So I think I can say Professor Raghava as a Dronacharya, as today morning our director sir was talking of. So he is making drones, and so I think our one of the program what we are going to take up again with the ICR and the precision farming program is sensor-based smart agriculture for crop and soil health monitoring, where drone making is one of the major component where Dr. Raghava is responsible for that. And as I told you, maybe Professor Raghava can tell with detail about the awards at the end of his presentation. So he has been with his team awarded many recognitions for drone making, and one of the famous is the Lockheed Martin programs, and also on roll of challenge of Lockheed Martin C-130. So with this brief introduction, let me request Professor Raghava to deliberate on drone technology and overview. And never he says no to me for any request I do. And I'm really thankful to you for your wonderful, warm acceptance and also ready to come in. So with this, I would request Professor Raghava for his presentation. Thank you.
Dr. Sahu, thank you very much. Can you please allow me to share the screen?
Yeah, please go ahead.
I think, is it visible?
It's not yet.
Oh, there is some problem.
Are you doing through sharing screen?
Yeah, I'm trying to do it, but I'm not able to get the screen. I'm just coming back, okay?
So this is what technological snag always it will be there. So this kind of tools and techniques. So please bear with. He'll be back soon. Your screen is shared. Go to the PPT. Yes, perfect. You are mute. Professor Raghava, you are mute.
I think, are you audible?
We are audible. Can you go on the screen mode? Complete view mode.
I have to be in this mode so that it will be easier for me.
No. And the down on the right hand side, third right hand side, from exit the second button, there is a setup, there is a window. After tips to the right.
What exactly you want me to do?
It will be full screen.
I'm in full screen.
If you click on that, it will be full screen.
Okay, 1 second. I'll come back. Is it full screen now?
Yeah, click on that. Click on that.
Yeah. Are you visible? Is it full screen now?
Yes, yes. Go ahead, please.
Okay. Are you able to see that?
Yes.
Okay. Unmanned vehicle systems is the university's daughter, which I can say that we initially started with a very small work and then gone to higher level, and it is it has shown both industry as well as academia. For the last decade, we worked with many industries and tried to develop UAVs with undergraduate students. Now, I can say that the overview, this is the outline which I am going to tell. It is overview of drone technology, the frames over the years which has been developed, and the team capabilities. Our team capabilities, recent developments, and achievements and projects which we had. Now, when I come to the overview, you know that the history of UAs field development in this field has been inspiring from early 1900s, and major milestones were achieved during the World War, such as Hewitt-Perry automatic aeroplane, and first remotely controlled scaled model aeroplane was designed by Renegade Denny in 1935, and after that, in the Vietnam War, Lockheed Martin has started B-21 with its first UAV for the surveillance. This is the evolution and revolution of the commercial or military and the humanitarian use of drones. Initially, the drones were used only for military origins, and after that they have been developed for humanitarian uses, which has been converted into commercial usage. So it shows the timeline of all the drones, how it has been evolved as well as revolutionized for different works. Types of drones, if you say, it is started with a single rotor, much like helicopters, with a large rotor along with a small one at its tail. So this is what which has been used as a single motor, and it is more efficient as compared to the multi-rotors. Similarly, bicopters have been used for the second choice. They have tried to develop two rotors in that, and two motors and propellers have been used, which are very cheap and offer a longer endurance. Flight control is complicated, but current results are very largely experimental. The third one was the third tricopters. This is cheaper to the quadrupter, no doubt, but it has a better endurance, and stability is also reduced, and the flight is jittery. So this jitteriness, if you have taken the stability of the film which you are going to take or video which you are going to take, that is not that much good. Then they developed what is known as quadcopters. In quadcopters, mostly they used forms that are drones, which are cheap and easy to manufacture also. And good camera control at the cost of reduced endurance has been achieved in this type of quadcopters. Then hexacopters have come, offer a more stable flight with backup motors in case of motor failure in an arm. But they are generally reach greater altitudes and maintain control over their flight in windy conditions. Then came the octocopters with full good flight control, are impervious to turbulent winds and often even rain. Excellent choice for high altitude aerial photography, but they are very expensive. Then came the fixed wing. Fixed wing, they are just like conventional aeroplanes, having a wing structure, high speed and endurance, don't have hover capabilities, and have low maneuverability also. Flying wings also has been developed. Tailless aircrafts without definite fuselage, and faster and aerodynamically more efficient than conventional fixed wings. Then another type of UAVs which have come is hybrid VTOLs. That means vertically takeoff and landing capabilities. These are multi-rotors and fixed wings. There are just it's a combination of both. So you can use it as a vertical takeoff, because you need not have a runway or something like that. So it can be used as a fixed wing, this one. And when once it goes up, it folds its wings and becomes like a quadrupter. So this is what it is, having both the features of quadrupter as well as the fixed wings. And applications of UAVs, I think this will be more widely specified by the persons who will be specifying about the applications. You can use it as disaster management, agriculture, wildlife conservation, signal strength analysis, infrastructure inspection, defense systems, mining, and traffic monitoring. Disaster relief, human detection capabilities are used to locate and provide relief material. It provides safe and accurate methods for analysis of unstable structures and easy removal of debris. The mobile towers based on UAVs are used for temporary communication services till damage to telecom infrastructure. So this is what I have. So I'm just going to show a video on this, how it has been deployed.
Professor Raghava, you have sound for this?
What?
Sound. Is there any sound?
Yeah, it is there.
The sound is not there. You are not. It's okay, no issue.
Sound is not there.
Ah. It's okay. Go ahead, please.
I don't know how to get the sound from this.
Leave it. Please go ahead.
1 second. Do you have any? I'm not able to get anything from there. Okay, as sound is not there, I'm just telling you this is the payload drop where this particular one video shows that. This particular video shows that how payload drop can be done and how the planes or the UAVs can make the formations, etc. Suppose if there is any hindrance which is coming, it will change the shape of the formation, and after once that the hindrance has gone, again it will form in this particular shape. So this is how this concept of operations can be done. And this is used for agriculture. I think I'm showing one more video.
In the video volume is off.
I'm not able to understand. Achha, okay.
Yes.
Is it sound is there?
No.
So this shows how you can spray the what you call the pesticides on the crops. So this we can use it. I will show you certain for certain things afterwards, which I have worked along with Dr. Sahu. And this is for wildlife conservation. We can identify the people where they are working and how they are working. Any other thing which you can identify about the concentration of the people and disaster management. We can identify the concentration of the people and do the payload. And drop the payload, sorry. And infrastructure inspection, while constructing, we can send drones like this, and we can see how exactly they are, the situation of working can be identified. Like in mining also, you can send the drones for stockpile and inventory management or issues of the through capability of aerial mapping and how this working of the condition of the workers. All these things can be identified for use for in the mining. This is traffic monitoring, how the movement of the traffic is there, whether they are violating traffic or traffic violations or first aid help can be made, etc. And this is signal strength mapping. This is one of the videos in which animation it has been done. Initially, my students have identified how to do it, and the structural analysis has been done, and then whether this structure will be used for one particular one thing or not, and how much altitude they should have, how much velocity it should be, and how the turns should be taken. Everything they have done it with using a video. So for this also you can use how to find the sound to noise ratio and a heat map of signal strength from various cellular devices in real time. All these things can be used, can be done using can be used by using the drones. And for defense systems, there are many operations which can be done for using different drones, and it has been shown here. And who can use UAVs? I think so many people can use UAVs. Everybody knows this one, so I'm not going to go in depth for this. And challenges in R&D of UAVs. This is the challenging areas we have specified at the right side, left side, and requirements for this challenging areas. Technologically and manufacturability. See, manufacturing of UAVs, it is mostly in India. They are not doing. They are importing the structure from outside, and then they are working on the electronics part of it. Most of the people they are doing like this. So with this concept, Lockheed Martin people have come and approached many universities in India, and they could identify us because they have seen us working sincerely for one of the competitions held in Maryland. In that, they have identified ourselves, and they came and approached us and asked us to do a project for them. They have given the specifications. Based on that specifications, we have fabricated the system in Delhi Technological University. So initially we had a lot number of problems, no doubt, but we could do their project within the specified time of 2 years. Then infrastructure, how it can be done, regulation and policies, this was another difficult level for us, and communicating engagement, how the UAV will be communicating the ground station, and how what type of antenna should be used, and how initially we used the RS-232 communication, then we have changed it to wireless communication, and then we have used some antennas which will be work in the particular range, so that proper communication model was developed by the students. And then the business model and partnerships which can deliver the UAV solutions. Community engagement also can be used. UAVs for military purposes and other special purposes, and make community familiar with their safety, their benefits, and their duration uses, and encourage R&D in UAVs, improve traditional methods, and some examples which I'm going to show you how it can be used. And when you see the market of drones in the world, it is excellent, and it will be going up in due course. So drones industry, you can see how the diagram is showing. It is continuously increasing day by day, and aviation sector is also using so many drones for so many applications. And in Asia, it will be one of the best marketing drone industry, and people are exposed to this drones, and many of them are working in this area. And in India particularly, there are so many drones working people, but most of them are companies are from America and other states only. But what we are doing is only one company, Skylab Drones. They are trying to mapping or surveying or inspection what they are doing. But recently there are so many other startups and other drone industry has developed. Because of this, many people are coming forward to work in this area. Indian drone market, I think I told you, it will be continuously increasing. You can see how IAF is using, or Indian other people are using for drones. Sir told that Alamurugan sir has said, allegation sir, he has told that there will be a lot of employment in the drone technology. Yes, that is true. So many people are coming forward to work in this area. So they require some guidelines and regulations which we have shown here, and these are the classified weights in for drones, and generally in our college, in our university, we are working on three, that is micro, small and medium. These are the three classifications of drones wherein we are working. So recent developments and breakthroughs, you can see that NASA is also has sent Mars helicopter Ingenuity, which has been sent to Mars to get the information. This is one of the this thing in July 2020 they have launched one aircraft, Zero Caters, to Mars, and they wanted to send they have already launched, and it will be reaching Mars on February 2021. And Dragonfly vital intelligence they are trying to use for breathtaking, this is for COVID, they are trying to get the information, breathtaking rate or heart rate and temperature and action. All these things have been taken by the people. About us, now I am going to tell you how our university has introduced into this drone technology, and what we are working on. So we are a research team comprising of undergraduate students of DTU, and with the help of faculty, the students develop, fabricate, and do the research on drones. What we do is we adopt evolving technologies to design, develop, and implement cost-effective solutions in the field of UAVs. And why we do it? Because it has a very high potential, and we can tap untapped capabilities of UAVs and try to use in society. So this is a team structure which we have, and we are working with different students at different levels. This is the departments with which we have. We have airframe department wherein design, fabrication, study of propulsion systems, payload drop, and support systems will be done. And avionics sees system integration, algorithm development, communication systems, embedded systems, and power systems. So, and the software people do computer vision things, code optimization, software stack, deep learning, and artificial intelligence. Frames over the works which we have developed in the past 2011 to 17, we have I have noted down here. But before this, our development has started in 2006, and Lockheed Martin has come forward in the year 2010, and they have given 2 years time to develop one UAV named as Arush X1, which has a payload of 8 kgs, operational in crosswinds of about around 37 kilometer per hour, and gusts of 46 kilometers per hour. Saying similarly, Arush X2, the second version of Arush, has been developed with this payload, and Arush, this is the third version of Arush, and another one, Amni, it has been in 2017 they have developed this particular UAV. You can see this video.
You're not able to see the video. Yeah, now it's. Since there is no audio, if you can explain them.
Audio, I don't know why it is not coming.
No, you can explain the video what you are showing.
Okay. I'll just start from little bit. This is in Karnal. We have, one second. Are you able to hear the voice now?
Yeah, better.
Huh? Here in Karnal, we have used this Anush X1. We have shown these are the waypoints which we have already entered into that. So based on this, the flight is taken from all the directions, and all the information has been processed on board, and the information has been sent to the ground station also. Here you can see there is a computer at the ground station. All the information can be seen here. This is the ground station which we have developed, and these are my students who are working on the ground station, processing the information at the same time. He is the operator who is going to see the landing and takeoff. So this is these are the other systems which we have used. These are the other systems which we have developed in 2018 and 2019 and 2000 different periods with VTOL, and these are the other systems which we have developed with quadrouters, which has been used for this turret was used for agriculture with Sahusar. And our capability shows that this is how the prototype development thing will be done. This is a manufacturing concept of fabrication or manufacturing concept. Initially, we go for conceptual design of any UAV, and then preliminary design will be done. Analysis of this and testing of this through software will be done, and once it has been obtained properly, then detailed design is done. So at the same time, we are trying to do the simulation, verification and validation. Suppose if there is any optimization is required, then it will be, again we will go to the detailed design and then we process that one. Similarly, in the preliminary design and the analysis and testing, optimization if it is required, we will go to that. Now, once the trade-offs are taken where with the problem statements. We understand that and try to take the trade-offs and constraints and try to develop the conceptual design. Once everything is over, then the simulation with verification and validation is over, then we go for the fabrication, and this, once it is fabricated, we test it in our university and see whether it is working properly or not. So the process of fabrication is, we have a 3D printing for developing the products. Wing fabrication also we do it using the molds, fuselage fabrication as well as vacuum bagging and all other things, we do it at our university level itself. The materials used for this fabrication is with high strength or weight ratio. The carbon fiber can be used because it gives a very good complete A-frame structure. Lightweight can be used for aluminum, can be used because it is lightweight for VTOL frames, and 3D printing materials can be used for PLA and ABS. And XPS foam, this is one more foam type material which can be used for easy shape. All these things we have utilized each one, and we try to develop each one and the other, and try to see how each one will be used. Balsa we have used, glass fiber also we have used, and we have developed different type of UAVs. This is one more video which you have it. This is the place where we have worked with Sahu sir. And we can and deployed some different UAVs like this, and we have developed different structures. We have designed analysis and stability control and system design, we have done it. This is the place where Sahu's work is done. The right one shows that infrared view of the quadcopter, and this is the fixed wing view of the video which has been taken with the hand launch. At present, we are working on the swarming of UAVs. These are the 4 UAVs which are shown in which is working on in our university for surveillance. So now these are the swarm planner also we have done it. So all the 3 UAVs are working here, moving in one particular direction. And communication systems also we have used. RF based true ad hoc mesh solution we have developed. UAVs with CGS communication range over 50 kilometers. This also we have developed. Scalability of swarms up to 50 UAVs. This we are able to achieve nearly 35 UAVs. Right now my students are working in Pokhran to develop another 15 UAVs that they have gone and they are working on this. We will be showing this 50 UAVs to Indian Air Force people from September 19 to 23rd. We have competition with Meher Baba, which I will be telling you in due course. And Wi-Fi based cheapest ad hoc mesh solution scaled up to 12 nodes also we could develop. And we have even developed what is known as GNSS denied navigation. That means if satellite system, global navigation satellite system is not there also, at that time also the UAVs will be in speaking to each other and they travel from one place to another without any hindrance, and once they go out of that, automatically the navigation will take over and they will try to switch to the normal this thing. So that is how it has been shown here, how they are capturing the image and then image processing, navigation controller as well as autopilot. How these things will be manipulated without having any hindrance. This is one of these videos which we are, with which it has been shown. So these are the outcomes with for DPS needed navigation. I think these things will be done by your Madam Shafali Madam, because they are going. She is going to explain completely how human detection or the image processing techniques are being used. And obstacle avoidance and path planning also can be done by using image processing this thing. We have developed an antenna also using HFSS, and we try to use this particular antenna to communicate wireless communication, so that the UAV will communicate directly the information to the ground station. This is an antenna tracking system which tries to give maximum information to us without any problem. The direction of the swarm is taken into consideration, and the complete swarm or the swarm of UAVs will move in one direction without having any colliding. And this is the paired up mechanism for a fixed wing. Microcontroller used for hardware design is this particular one. This is the indigenous flight controller which we use it. And the projects, if you see, this is the achievements of the students which they have got it. So nearly 10 years, each group, how we frame the group is first years when they come, we will have interviews and other things, rigorous interviews with written tests and interviews. After scanning all of them, we will select only 20 students, and those 20 students will be trained for all the work from first year, second year, third year, and fourth year. The fourth years will be the working as project managers. The third years will be working actually on the system, and the second years will be supporting the first years and second years will support the third years, and they have heads, and those heads will be trying to control these people. Every weekend we will have interviews, discussions of the things, and at the end we will come to finalize the information. So this is the first opportunity we have got it. That is, Lockheed Martin has come forward, and they have given us competition. Sorry, they have given a project for us for 1.75 crores, and the second was around 25 lakhs. So these are the challenges and mitigations which they have given it to us. So based on that, we have developed the mission to them. So this is the students who have got accolades from AUVSI competition. So in the first level, 2009, they got one director's award, and in 2014 they were third overall. That means in the world they were the third. We achieved the third position. So this is another place where we have gone for competitions. This is for SAE Aero Design. Always we got first position for the past 2 years, and this is a competition which we are going for from September 19. If we win, we will be getting nearly 100 crore project, which I wish that my students will surely try to do that one. Thank you very much for your kind, patient hearing, and other information will be passed on to the next speaker. Thank you very much.
Thank you, Professor Raghav. Wonderful lecture, starting from drone making to possible applications and also advances in swarm techniques, mother and child in case of drone for various applications. And thank you for wonderful deliberations. I think there are many questions raised by participants, but a few of them which are applicable to you is one question was what are the advantages of fixed and quadcopters when they are to be used, when the fixed wing and when the quadcopters?
Okay, see, fixed wing, when you see that, say when you want a video at a very high level altitude, at that time fixed wings are very easily manageable. But if you want very, suppose the crop is very small and you are in the starting days of your sowing the seeds and other things, and understanding of the soil, if you want to do it, the height of the drone should be very less. Then you will get a clear information about these things. So better not to use a fixed wing, you have to go for a quadrupter. And when you use a fixed wing, you have to see how the wind is flowing and whether it is suitable conditions are there or not. Just like that, you cannot go for that. And another fixed wing problem is you have to take permission. Quadrupters, you can make them to go only up to certain feet, and you can row over them, the field. But that cannot be done in case of fixed wings. So fixed wings will be used only when it is very long distance. This thing is there. Suppose surveillance, if you want to do it, you can send it very deep into forest, or inclined plains are there. At that place, you have to use a fixed wing rather than a quadrupter. how we are doing it is, we have a planes which will go to one certain stage, and within that we have quadrupters. So where the plane will go to one certain distance, from there the quadrupters will be dropped to the certain area, and there the quadrupters can pick up the information and come back to the plane, and they will come and settle down in the plane, and then the plane comes back here. Then we can take the information from the fixed wing, the quadrupters, then it can be done. So hybrid systems can always be suitable. So you have to think how much height it is there. If it is very high, then better use fixed wings, not for quadrupters. When the height is small, better use quadrupters, not the fixed wing.
Thank you, Professor Raghav. Next question is how we can decide the drone propeller diameter and BLDC motor size according to payload for fabricating a drone, and then what are other parameters should be considered for designing a low capacity spraying drone?
See, this all depends on the fabricator, designer. So the parameters exactly I will not be in a position to tell you, because it is trial and error methods. We have to see all those things depending on the specifications. So each quadrupter is defined for one particular this thing, and it will be different. So don't assume that only with these parameters we can get it. So then and there also there may be so many changes which we have to make it. So it all depends on how we are trying to go for that. I'm not in a position to tell exactly these are the things which you have to do it.
Thank you. And there is a question whether your drones are available for market to be purchased. If it is, what is the cost?
Oh, okay. At present, we are still in the research in this thing only. We in due course we are thinking of, because we are having now acquainted with Adani people. So they have come forward, and they will be manufacturing this. Fabrication and manufacturing will be done by Adani people. So in due course we will be having this decision of making and fabricating and selling of drones. As of it, I can say no.
Okay, since endurance of the drone depends on the battery you use most of the time and the payload, can we use solar powered energy for drones?
We can use the solar power energy. We are trying to develop that one also. The reason is, when if a battery gets failed, then immediately you have to get the drone down. Otherwise, if the drone falls off anywhere, then it will be a lot of problems. This we could even observe in IARI. Once it happened in such a way that the battery suddenly failed, and it went and fallen in the ground only, but it did not give any problem. So you have to be very careful. Battery backup, you have to have it, but still the endurance, if it is for 1 hour or 1 hour to 10 minutes or 20 minutes, you have to fly only for 45 minutes. That will be better. So it will be very difficult for you to do this one. So we can try for panels of panels, but the solar panels is nowadays it is coming in a different structures. So on the top of the fixed wing drone, they are trying to develop the wings. On the top of the wings, they are trying to have this panels, and they are exposed to sun, and that energy has been taken, and it is utilized for that. So this can be done. We are also trying for this particular concept.
I think you have answered also some of the other questions related to the battery and also energy use. Some people have said how ultra-fast charging UFC can be used for drone so that we can have a better endurance. And one question they were asking is, how do you manage the dragging force of the wind in case of drone while you design that? Aerodynamics forces and wind.
See, we have one thing. When we design itself, we have to be very careful. In actual scenario, it is totally different. Even though if you see the weather and other things, you have to be very careful and then fly it. Suppose if weather gets bad, you have to immediately bring your drone back. You cannot fly it in that scenario. This happens. So, see, that is the reason why people are not giving certification and other things. They are very much strict over, and they are not allowing for drones to fly. This is the problem, no doubt about it. Endurance is, if it is very high also, still the problem exists. So we have to take care of that. I think your design concept should be very perfect. That only is the solution.
Thank you, Professor Raghav. There are many other questions which is not relevant to your deliberations. Maybe later it will be answered.
Or you can send it. We can make it this thing and distribute to the participants. There will not be any problem.
Right. So maybe there are some questions which is relevant to the subsequent speakers. We will note down those questions and we'll ask them. So with this, we give a great thank to you, Professor Raghav, for sparing such a valuable time and deliberation and effective interaction. Thank you very much.
I once again thank you all the persons who are involved in this webinar, and it is very difficult to contact the people and try to develop like this, and I appreciate the efforts of Sahuji, who has contacted all of them and tried to have this type of a seminar. Thank you very much for one and all, directly and indirectly, who are involved in this conducting of this webinar. Thank you very much.